Okay, let's unpack this. For generations, people have looked up at the skies and wondered. I mean, we've seen baffling lights, right? Unexplainable movements, objects that seem to defy everything we thought possible about flight. For a long, long time, these unidentified flying objects, or UFOs, well, they were largely dismissed, kind of relegated to science fiction or, even dismissed as fringe conspiracy theories. But recently, something fundamental seems to have shifted. Governments, major scientific institutions, they're now actively engaging with these sightings or even rebranding them. Unidentified Anomalous Phenomena, or UAPs. So today we're taking a deep dive into your sources to try and understand what's truly at play here. We've got detailed analyses from former NASA scientists, some really compelling first-hand accounts from military personnel, and even cutting-edge scientific proposals. Our mission: let's try to separate the signal from the noise and look at these phenomena squarely through the lens of engineering and physics. Get ready for some truly illuminating insights that might just change how you look at the sky, and maybe even what you think is possible within physics.
Yeah, what's truly fascinating here is just the sheer volume of data. Data that's been quietly collected over decades, really, just waiting for serious, unbiased scientific scrutiny. And we're going to explore how observations that once seemed to just outright defy the laws of physics might actually be entirely consistent with them. It's just perhaps leveraging principles and technologies far beyond our current capabilities. The real aha moment here is often realizing how much more there is to learn within the existing framework of physics.
Right. So if we're approaching this from that engineering and physics angle, let's start with maybe the most basic question, one a lot of people still grapple with. Are these things even physical? Are they actual objects? Your sources mention the incredible work of Paul Hill, a highly respected NASA aerodynamicist who dedicated a big part of his life to exactly this.
Hill was, an absolutely brilliant engineer, known for his rigorous scientific approach. He had personal UFO sightings back in 1952 and then again in 1962. For him, these weren't just dismissible anomalies. They spurred him to meticulously collect data from other scientists. He was determined to prove that these objects, he preferred to call them field-vectored craft, or FVC, actually conformed to the laws of physics rather than defying them. His book, it came out after he passed away, Unconventional Flying Objects, a scientific analysis. It's really a testament to his methodical work, applying known engineering principles to these seemingly impossible observations.
And he wasn't just, thinking about it in theory, was he?
Yeah.
He actually took his ideas into the lab, built and tested early flying platforms, things that could replicate some of the maneuvers he'd observed, showing they were, controllable and potentially explainable.
Indeed. His work provides really compelling evidence for their physical reality. He looked at cases like the Alucia, Spain incident in 1966. A luminous disk reportedly left 3 distinct rectangular landing gear imprints, nearly 5 inches deep, in very hard soil. Imagine the force needed for that. Then there's the Quarouble sighting in France, 1954. Eyewitnesses described a football-shaped object about 6 meters long. It left 5 remarkably deep indentations in solid wooden railroad ties. Based on these physical traces, Hill meticulously calculated its estimated weight. Around 30 tons.
30 tons, wow.
Yeah, exactly. And what's truly fascinating is his calculation of the density. 965 kilograms per cubic meter. That's roughly 96% the density of water.
So comparable to a submarine, then. Much denser than a plane.
Right. Several times denser than a typical jet aircraft. It really points to something substantial.
So the aha here is we're talking about something with serious mass, serious density, which implies a craft that could, plausibly anyway, operate underwater as well as in the air, not just some trick of light or weather balloon.
Precisely. And Hill, he painstakingly documented numerous other cases showing their solidity. There were reports of bullets ricocheting off a craft back in '67, or that astonishing account of boys actually tapping on one with a flashlight in 1974.
Tapping on it.
Yeah, confirming a hard metallic surface. These aren't just visual sightings. These are interactions with solid, massive physical objects, which makes them absolutely amenable to rigorous engineering and scientific analysis. It shifts the whole conversation from do they exist to, okay, how do they work?
Okay, now if these are solid, massive craft, the next question, and this is where it gets really interesting, how do they move like that? We hear reports of speeds, accelerations that seem just utterly impossible for anything we've built, like that B-29 bomber incident in 1952 you mentioned. Radar tracking craft moving between 5,000 and 9,000 miles per hour.
And the accelerations, they're even more astonishing. Maybe the toughest part to reconcile with conventional physics. Paul Hill's own observations, and of course the famous 2004 Nimitz Tic Tac incident. Kevin Day, he was a radar expert closely involved in the Nimitz event. He described objects descending from 80,000 feet, just hovering, and then dropping almost instantly from 20,000 feet to just 50 feet above the ocean in 0.78 seconds.
0.78 seconds.
Yeah. That implies accelerations.
Yeah.
Well, hundreds of Gs relative to the environment.
But wait, wouldn't that kind of force just crush anything inside? Or even tear the craft apart? I mean, our bodies can't handle anything near that.
That's the crucial question, isn't it? And while, yes, those accelerations are way beyond what a human pilot could take in a normal aircraft, Hill's brilliant analysis points out that materials can actually withstand such forces, but only if the force is applied in a very specific way. He gives examples, like bazookas experiencing hundreds of Gs when fired, or U.S. Army cannon-launched projectiles designed to endure 7, maybe 9,000 Gs. The key difference, and this is the aha moment, is if the force is applied uniformly to all the mass within the craft at the same time, almost like creating a localized gravitational field. Then the craft and everything inside, including occupants, wouldn't experience those crushing internal G-forces. They'd essentially be weightless inside that accelerating field.
So it's not just the amount of force, it's how it's applied. That's a completely different way of thinking about propulsion.
Exactly. Hill stressed that while the maneuvers might look instantaneous to us, they are technically sudden. They take a finite, though incredibly short time. This implies extremely high thrust-to-weight ratios and incredibly precise thrust vector control. These are concepts within engineering just, well, far more advanced than what we can currently do.
And the energy needed for that kind of performance, it must be staggering. Dr. Eric Davis, another key voice in your sources, he speculates the energy for the observed features, especially the Nimitz Tic Tac, could be hundreds of times the total energy produced in the entire United States annually. That's astronomical.
It truly is. And this huge energy requirement, it naturally leads to speculation about propulsion. Paul Hill, with his characteristic boldness, he proposed a directed acceleration field, essentially a kind of gravity-canceling force field. Imagine this. Such a field creates a constant pressure zone around the craft, almost compression-free. This is incredibly important. It would prevent sonic booms. It would eliminate aerodynamic heating, letting them travel at Mach 4 or 5 times the speed of sound without melting or burning up. The air just approaches the field and springs away, deposits no energy, almost no drag.
So it's not plowing through the air. It's more like the air is actively pushed aside, creating its own clear path. That's revolutionary for high-speed flight.
Precisely. And another idea explored in the sources is ion propulsion. Major Alexander Peter-Seversky demonstrated his ionicraft back in 1964. These experimental things flew silently, just on electricity. Use negative voltage to create an ion wind, a downdraft for lift, no moving parts. The theory suggests you could scale this up, potentially to unlimited size, reach high speeds, and steering, just by varying voltage across different parts of the craft. An elegant solution for silent flight.
And then there's even more, well, radical speculation from Dr. Davis. He considers the possibility of something as mind-bending as teleporting energy from some remote, distant location to power these craft, which would certainly explain why we often don't see obvious power systems or exhaust.
Yeah, it challenges our basic assumptions about energy generation and transmission.
Okay, let's shift to how they look. That distinct glow many witnesses report. What's behind that consistent visual?
Hill's analysis, again, offers a compelling scientific reason. He suggests it's a plasma sheath, basically ionized and excited air molecules surrounding the craft. The light isn't coming from the craft itself, but from the air around it, energized by its propulsion system. And the color of this plasma can actually tell you something about the craft's power output, red and orange. Common for lower power stuff, like hovering, needs little energy. Blue, white, especially blue-white, that's associated with high-power, high-speed maneuvers because elements like nitrogen get highly excited and emit light strongly at those colors. And the brightness. It also increases dramatically with the power the craft is putting out.
So the light isn't just decorative, it's a direct byproduct, a visible sign of the immense energy interacting with the atmosphere. That's a critical aha.
Exactly. And this also clears up a visual paradox people report. The plasma can become opaque, right? So if you look directly at a nearby part of the craft, you might see its metallic structure, sharp lines. But if you try to see the whole outline, you have to look through a thicker layer of that glowing plasma. That results in an indistinct blur because the light gets reabsorbed. It's a natural optical effect of the plasma, not cloaking or anything like that.
Beyond these optical things, which definitely point to physical interaction with the air, have we ever actually found pieces, physical artifacts.
Well, the Ubatuba magnesium fragments are a classic case, though still debated. Back in 1957, fragments were reportedly recovered in Brazil after a UAP incident. Lab analysis later showed this magnesium was exceptionally pure, way purer than commercial magnesium, and remarkably 6.7% denser than ordinary pure magnesium.
Denser.
Hill calculated this could be explained if the sample contained only the pure isotope Mg26, that's a specific, slightly heavier version of the magnesium atom, instead of the natural mix of isotopes we find here on Earth. Now, significant isotope separation like that, to that degree of purity, it's usually only seen in very specialized terrestrial processes, like uranium manufacturing. So this finding is highly anomalous. It certainly suggests non-terrestrial manufacture.
And Dr. Eric Davis builds on that, right?
Yeah.
He mentioned materials recovered or observed often seem to be combinations of elements from our periodic table, isotopes included, but mixed and structured in ways we just can't replicate today, implying material science way beyond us. Wow. The whole conversation is definitely giving me some serious aha moments about what might be genuinely possible. It really sounds like there's a strong push now, a concerted effort to bring this stuff into mainstream science, to finally shed that stigma.
Absolutely. That's why the U.S. Department of Defense coined the term UAP in 2022. It was precisely to reduce the smirk factor, the stigma tied to UFO. It actively encourages more open reporting from pilots, intelligence folks, even the public. And agencies like ARO, the All-Domain Anomaly Resolution Office, were set up specifically as central clearinghouses for government reports to foster a more rigorous approach.
So when all these reports come in, the new sightings, historical ones, where do most end up? Is it always something exotic?
Not at all. And that's a really critical point for balance here. A 2023 study found sightings were often boosted near airports or military bases, which strongly suggests a significant number can be attributed to conventional things. Sometimes classified or experimental aircraft, advanced drones, rockets, stealth tech that the public wouldn't recognize. People like Mick West from metabunk.org have done great work showing how seemingly mysterious lights, like over the Great Plains, can be definitively identified as Starlink satellites, for instance.
Right, the mundane explanations.
Exactly. The truth is often more mundane, but the real challenge is to rigorously filter out the explainable from the truly anomalous. That takes objective analysis.
And that kind of filtering, that objective analysis, it needs much better data, doesn't it? Our current systems just weren't built for this.
Crucially, yes. Current aircraft sensors, they weren't designed for multispectral UAP detection or to measure those extreme kinematics we talked about. That's why projects like the Galileo project, led by Harvard astronomer Avi Loeb, are so vital. They're actively building ground-based observatories with full suites of sensors, high-res cameras, radio antennas, magnetometers, microphones, specifically to collect robust, comprehensive data in hotspot areas. The goal is simple: determine scientifically what's normal versus what's genuinely not. And if you connect this to the bigger picture, Dr. Eric Davis mentioning the lack of physicists in highly classified government UAP programs, that highlights a really significant, almost ironic gap.
That does seem like a pretty glaring omission if you're trying to figure out advanced physics, like trying to understand a new engine without an engineer on the team.
It really is. The legacy program, as it's been described, seems very insulated, which hinders bringing in new talent, new theories, maybe to focus on intelligence gathering instead of fundamental science. And that's unfortunately slowed down our collective progress on these huge questions.
And just thinking about the human side, Kevin Day, the radar guy from the Nimitz incident, he described how profoundly these encounters affected him personally. It wasn't just some interesting blip on a screen, it was life-altering. Even led to career setbacks when he tried to speak out. He talked about data from their sighting being wiped by people in suits, though apparently a snippet was saved that confirmed that insane 0.78-second drop.
Day's experience is such a powerful reminder of the human element. He describes the encounters as fundamentally changing his life. Unexpected shifts in interests, career path, everything. He's even gone on to theorize that intention itself might be a fifth fundamental force in the universe. That's a deeply personal conclusion he's actually trying to develop mathematical models for.
Yeah.
It just shows how these experiences can force you to completely rethink reality. His message to anyone who encounters these things is profound. Don't be afraid. Don't try to profit from it. His deeply held belief is that they want us to evolve, to improve ourselves, expand our consciousness. It points to something deeper, almost philosophical, beyond just the physics.
It really sounds like a journey of profound personal and scientific discovery, and one that's still very much unfolding for a lot of people. So, wrapping this up, what does it all mean for us? We've seen that these objects in our skies, call them UFOs, call them UAPs, they're increasingly being treated as a serious engineering and physics problem, not just a fringe curiosity. From their estimated mass, their incredible speeds, the way they interact with the atmosphere, these phenomena challenge our current understanding, but maybe, just maybe, offer glimpses into future tech. The aha moment is realizing that what seemed impossible might just be physics we haven't figured out yet.
And if we connect that to the bigger picture, it raises a huge question, right? If these objects really are using physics principles we're only starting to grasp, like Hill's-directed acceleration fields or maybe energy teleportation, what does that imply about our own technological future? Could understanding this stuff not only help secure our airspace, but maybe unlock entirely new realms of propulsion, clean energy? Could it reshape our whole civilization?
Imagine the possibilities. This deep dive really shows us that sometimes the most groundbreaking knowledge isn't about defying the laws of physics. It's about revealing just how much more there is to learn within them. Perhaps the next giant leap for human innovation is actually staring down at us from above, just waiting for us to truly open our minds and our scientific instruments to what's really there, and to the profound implications of finding out.